So in this video, we are going to discuss about voltage to current converter. So this is also called as transconductance amplifier. That is my I0. I0 is your output current, that is equal to K by VI. Okay. So here K is a constant. Okay. And it is K is independent of the controlling voltage, right? Controlling voltage VA. So I can write, since it is a transconductance amplifier, I can write I0 is equal to GM into VA. Okay. So this I can also write it as I0 by VA, or I can write it as IL by VI. Okay. So we need to find the value of GM. Okay. So here it is called as an voltage controlled voltage source. Okay. This is called as voltage controlled current source. Sorry. Voltage controlled current source. We have two diagrams which we are going to discuss. Okay, so this is your RL and this is your R1. Okay, so we know that IL is your current, output load current. So since the current through this opamp is 0, so I can write this one as okay. I can write this current as IL. Okay, and the current flowing through this one is 0, so this current is also IL. Okay. So since this point is VI, okay, this point is also called as VI. Okay, so I can write VI is equal to IL by R1. Okay, so therefore what is IL by VA? IL by VA is equal to 1 by R1. Okay, so this is nothing but a transconductance, right? So so this circuit is called as voltage to current converter with floating load. Why it is called as floating load means so neither side of the RA. Okay, so neither side of the RL is not grounded. Either side of the RA is grounded. Okay. So here also it is not grounded. So here also it is not grounded. So it is called as a floating load. Okay. So let us now discuss about a voltage to current converter with grounded load. Okay. So here you can see I have used two resistance. And this is your RF. Okay. And the current flowing through this one is I2. Okay. So here you can see it is the RL value is grounded. Okay. So from this I can write it as what is my IL? IL is equal to I1 plus I2, right? So how can I write the IL? IL is equal to, so this point is nothing but, let me term it as VA. Okay, this is VA. So IL I can write as VL by RL, right? This is VL by RL. What is I1? I1 is equal to VA minus VA divided by R. VA minus VA divided by R plus I2. What is I2? V0 minus VA. This is nothing but VA. Okay. So this I can write it as VI minus VA divided by R plus since it is VA, the current flowing in this direction, right? This is also I2. Okay, so I can write this point is nothing but VA. So I can write VA minus V0 divided by R. Okay, so if I solve, I will get the VI minus V0 divided by R. So what is V0? V0 is equal to 2 times VA. Why? Because it is 1 plus R divided by R into VA. So R get cancelled. So you will get V0 is equal to 2 VA. Yeah, V0 minus VA. V0 minus VA divided by RF. And here I can write it as phi 2 is in this direction. Okay, I can write V0 minus VA divided by R. Okay, so I can write VA plus V0 minus 2 VA is equal to VL by R. So now I can write IL. This is nothing but IL, that is equal to we know that V0 is equal to 2 VA, so I will get VI by R. So that is nothing but GM into VA. Okay. So GM is nothing but your trans conductance. So its unit is Siemens. So here you can see the IL is independent of R. Okay, it is load resistance. And also the direction of the current. The direction of the current. Current IL. Right? This load current is controlled by the polarity of VA. So we know that the input impedance of the circuit is very high. Therefore, the current it draws from the source is very less. So this one is used in Zener tester application. Zener tester, next one is an LED, and the third one it is used in the low voltage voltmeter. So we have to make sure that while designing the RL and RF, okay, RF values are very small. The current, the output current, right? The output current is becomes high, right? So this will pushes op-amp to saturation, right? So next, if RL and RL and RF are very high, then the output voltage exceeds the power supply voltage. Next, since the product value of the two resistance and IL make the output voltage.